Welcome to my channel. In this video, I'm going to discuss how to write the laboratory manual for one of the electrical circuits laboratory experiments, that is DC transient response of RL, RC and RLC circuit. DC transient response of RL, RC and RLC circuit. So before discussing how to write the manual, if any student is watching this video, they must know how to write down the manual in their observation or record. So what are all the rules they should follow, that I will discuss first of all in the next slide. So if this is your observation notes, these are the this is our right side page and this is our left side page. So on the right side page, first of all you must write the title, date and experiment number, and in all the right side pages you must write this content. The content is aim, apparatus required, theory, procedure, formulae, calculation, theoretical proof, practical proof, precautions and result. This sequence, it has to be followed as it is, and all these must be written only on the right side pages, and on the left side pages you must draw the circuit diagram, observation table and model graph. So for this experiment, that is transient response of RL, RC and RLC circuit, you don't have to do any calculations. You will not have any theoretical proof or practical proof. So this slide is in general applicable for all the electrical laboratory experiments. So I have prepared this for in general, not for specifically for this specific experiment, in general for all the electrical laboratory experiments. So this calculations, theoretical proofs, formulas are also not there. Formulae, calculations, theoretical proof, practical proof will not be there for this particular experiment. So let us get back to our concept. The title of our experiment is DC transient response of RL, RC and RLC circuit. So if you are a student, if you are copying this manual in your observation notes, then you can pause the video to write down the content. Aim of this experiment. Aim of this experiment, I have categorized this aim into two categories. Because I want to do this experiment using hardware as well as using MATLAB software. So the first part of the aim is to study and plot the DC transient response of RL, RC and RLC circuit using hardware. The second part of the aim is to study and plot the DC transient response of RL, RC and RLC circuit using MATLAB software. Now, the apparatus required to do this experiment, for hardware experiment, the apparatus required, they should be always written. The apparatus required should be always written in a tabular column. The first column should be a serial number. I have not included the serial number here because I wanted to increase the font size of this this content which I have written here. So in order to increase the font size, I had to delete the serial number column. So you people can add one more column. First column is the serial number, which is not shown here. The second column is name of the equipment, next range, type and quantity. So the equipment that are required are signal generator, CRO, decade resistance box, decade inductance box, decade capacitance box, voltmeter and connecting wires. So the signal generator that is required, its range is around 0.1 Hz to 10 megahertz, and we need one signal generator. Signal generator, you can even call it as a function generator. You need a CRO of range 20 megahertz and which is dual channel type, and we need only one CRO. We need a decade resistance box, one quantity. You need decade inductance box, one quantity. Decade capacitance box quantity required is 1. Voltmeter that is required here is of range 0 to 10 volts, and type is rectifier type voltmeter, and we need only one voltmeter. And depending on the um, requirement, the connecting wires you can write as required or required number. So the quantity of connecting wires is never specified. You can take some bunch of wires, as many as required you can connect, remaining you just leave. So you draw the tabular column. You can pause the video to draw this tabular column in your notes. For the software experiment, the apparatus required is only MATLAB software. That's why I have written only one row with 2 columns mentioning software required is MATLAB. Okay. So the software that is required is what? MATLAB software. That's it. So the circuit diagrams. So here for doing the hardware experiment for RL circuit. Okay, for RL circuit, in order to get the DC transient response of RL circuit. So this is the circuit diagram, hardware experiment circuit diagram. You need a function generator. You must give DC step input using this function generator to the R and L. R value is 1000 ohms and L value is 1 Henry. And you must connect a rectifier type 0 to 10 volts voltmeter across the function generator. So as I have already told you, in the apparatus required, I have mentioned signal generator. Signal generator is nothing but function generator. Okay, signal generator or function generator, both are same. Okay, next circuit diagram for RC circuit, where R value is 1000 ohms and C value is 2 microfarad. Resistance value is 1000 ohms and capacitance value is 2 microfarad. Okay, they both are connected in series. Okay, they are connected in series and connected across a function generator. So function generator, using signal generator or function generator, we are going to give DC step input to R and RC elements which are connected in series, and whatever voltage, step input voltage that is given to R and C is measured by an voltmeter of range 0 to 10 volts and of type rectifier type. Next, RLC circuit. So here resistance, inductance and capacitance. Resistance, inductance and capacitance, they are connected in series, and resistance value is 1000 ohms, inductance value is 500 millihenry and capacitance value is 0.2 microfarad. Okay, so they are connected in series, and function generator or signal generator is connected across these across these elements, and using this function generator we have to give a DC step input to these elements, and the voltage that is applied using this signal generator or function generator, that voltage is measured by a 0 to 10 volts rectifier type voltmeter. You can pause the video to copy down this hardware experiment circuit diagram in your notes. Now let us see the circuit diagrams for doing the software experiment. So first of all, for RL circuit, so here this is our resistor of 1000 ohms, inductance of 1 Henry, both are connected in series. They are connected, voltage source is connected across R and L, and to this voltage source we must connect a pulse generator because we want to give a pulsating DC input here. That's why pulse generator is connected. And across the inductor, we want to measure the output voltage. So across inductor, connect a voltage measurement, and output terminal of the voltage measurement is connected to the scope. So the pulse generator input is given to the scope and voltage measurement is connected to the scope. Therefore, the scope, when you debug and run this circuit, you will get both input waveform as well as transient response waveform. And you also require a power guide, so you must from the Simulink library, you must type power guide, POWER GUI power guide in the Simulink library, and you must copy it and paste it in your model. So you just copy it. Next, circuit diagram for RC circuit. So this is our source, and here this is our resistor of 1000 ohms. So this is our capacitor of 2 microfarad. So these two are connected in series, and this voltage source is connected across RC, and to this voltage source, pulsating pulse generator is connected, and we are going to measure the output voltage across the capacitor. Therefore, voltage measurement is connected across the capacitor, and the output terminal of this voltage measurement is given to the scope. So even input pulsating generator input pulse is also given to the scope. So we can see both input voltage as well as response of RC circuit when you debug and run the circuit. You can pause the video and copy the circuit. Now let us see the software. In order to do the software experiment, the circuit diagram that is required, or the circuit that you have to develop using MATLAB software for RLC circuit. So you have to take the resistor of 1000 ohms and connect it to the inductor of 500 millihenry, and inductor output terminal should be connected in to the capacitor of 0.2 microfarad. So this is 0.2 microfarad. So I think it is it may not be clearly visible, so I am writing it here. So C value is C value is 0.2 0.2. So I'm unable to write 2 here, but I am trying my best. 0.2 microfarad. The L value is 500 millihenry. Resistance is 1000 ohms. So all these RLC elements are connected in series. Across these series connected elements, voltage source is connected, and a pulse generator is given as input to this voltage source. The pulse generator is also connected to this scope. Pulse generator is also connected to this scope, and we are going to measure the output voltage across LC. So voltage measurement is connected across LC, and output of this voltage measurement is given to this scope. So when you debug and run this MATLAB Simulink block, what will happen is you can see both the input voltage as well as output response, okay, by double clicking on this scope. So you can pause the video and you can copy down this circuit diagram in your notes. For each and every Simulink block diagram that you are going to design using MATLAB, you must also copy down this or you must also select this block from the Simulink library. This block is Power GUI, POWER GUI GUI. Now theory. In order to write the theory, you must leave at least one page in your observation, and you can refer to some textbook to write the theory. So students should always refer to the textbook to write the theory. Next procedure, let us see the procedure for this experiment. For hardware experiment, connect the circuit as shown in the figure. For for series RL, RC and RLC circuit, set the DC step input voltage from the function generator or signal generator of 1 volt and observe the input waveform in the CRO. In RL circuit, to observe the transient voltage response, connect CRO probe across the inductor and observe the output voltage waveform in the CRO. Next, the procedure continues. In RC circuit, to observe the transient voltage response, connect CRO probe across the capacitor and observe the output voltage waveform in the CRO. Next step, in RLC circuit, to observe the transient voltage response, I think there is a mistake here. So in RLC circuit, to observe the transient voltage response, connect CRO probe across inductor and capacitor. And I'm sorry. And observe the output voltage waveform in the CRO. Next, calculate the time constant of RLRC circuit transient response and tabulate it. No need of this step. Directly we are going to plot the waveforms here. So no need to calculate the transient response here. So we are going to just study and plot the waveforms. That is our aim. That's why we are not going to calculate that. You can calculate the transient response, time constants from the response, but in this segment, they have just asked us to study and plot the transient response. That's why I have removed that extra point. So now for software experiment, procedure is enter the command window of MATLAB and create new model by selecting first of all file. After selecting file, select new. After selecting new, select model. So in that model, you have to pick up the blocks from the Simulink library browser, and after picking up all the blocks from the Simulink library browser, you must connect all the blocks. After giving connections, you have to set the source values and parameter values. After that, you must debug and run the circuit, and as soon as you debug and run the circuit, you can see the waveform on the screen. And these are the model graphs for DC step input and response of RL circuit. So you can see on the y-axis, you can see V in input voltage, which is the DC step input. So this is unit step. If you carefully observe, this is 0 and this is 1 unit step input I have given, and the input voltage with respect to time, and output corresponding to the input, you will get the output voltage with respect to time. You can see for RL circuit, this is the response, transient response. Response means output. So output voltage is nothing but the response for the DC step input for RL circuit. So whenever we are drawing the model graph, no need to specifically mention the x-axis scale and y-axis scale. No need to copy down. Even so, you can see it is hardly visible. Okay, it is barely visible here, x-axis scale and y-axis scale. So for model graph, scale is not required. Now let us see the response of RC circuit, DC step input and response of RC circuit. So this is our DC step input, V input, and this is the V output of RC circuit. So both are plotted with respect to time. Pause the video and just draw this model in your observation or notes. Next, DC step input and response of RLC circuit. So this is our DC step input, V input, input voltage, DC input voltage, and this is the response of RLC circuit, that is output voltage with respect to time. You can pause the video and copy down this waveforms in your observation. Next, precautions. You must avoid loose connections, avoid parallax error while taking readings. And at last, result. So in the result, you must write DC transient response of RL, RC and RLC circuit using both hardware and MATLAB software was studied and plotted. Thank you for watching this video. If you have any queries, you just mention in the comment section. If you are able to follow, you just click on the like button. If any part of this video which you were unable to understand, then you can mention in the comment section. Thank you.